There are certain circuits in which the resistances are either in series or parallel. While simplified the network reduction, which cannot be simplified by series or parallel rules which we have. Series resistances, if they are connected in series, the equivalent resistance is sum of the two resistances or three resistances. If they are connected in parallel, 1 by R1 equal to 1 by R1 plus 1 by R2. The equivalent resistance which when connected in parallel or series you can solve, but it is very difficult to calculate the equivalent resistance. Some resistances are connected in parallel and series like that. Under these conditions, it may be necessary to convert the circuit from one to another to solve any unknown quantities. Two circuit configurations mostly we are using. One is star and another one is delta. A star circuit is one in which similar ends of three resistances are connected together to a common point is called neutral point or star point it is also called. It is also called Y connection or T connection because of its shapes. So many shapes present in star connection. One is star connection or T connection. It is also called as Y connection. Sometimes we can say that it is a star or Y or T. And another one is delta circuit. A delta circuit is one in which dissimilar ends of three elements are connected together. It is also called mesh connection or pi connection. The delta circuit. First we go for delta to star transformation or conversion. How to convert delta to star? If the circuit consists of delta connected resistances RAB, RBC, RCA, like this in this diagram, RAB, RBC, RCA or RAC are connected in delta, you can see in this diagram. In this circuit, convert delta to star, that is RA, RB, RC are the three resistances which are connected in star. The equivalent resistance, how to convert delta to star? By using simple solution we can convert. Resistance between terminals A and B in delta. The resistance between terminals A and B delta, the RAB is in parallel with other resistance RAC and RBC. One thing we have to remember that when resistances are connected in parallel, 1 by R equivalent equal to 1 by R1 plus 1 by R2, that equal to R1 R2 by R1 plus R2. That is the actual formula to calculate when resistances are connected in parallel. Similarly, when resistances are connected in series, R1 plus R2 plus R3. But network, in this network, it is a network, delta connected network, we are converting into star. Resistance between terminals A and B in delta is equal to resistance between terminals in star. That is, RAB is in parallel with the combination of RAC. The parallel combination it consists of. RAB is in parallel with RAC plus RBC. That equal to RAB. The terminals between this is RAB. It consists of. This is this one. You can see this one. This is RAB. RA plus RB. Across this arm we have star terminals RA, RB. That is RA plus RB equal to RAB is in parallel with RAC plus RBC. Now you can convert this equivalent resistance. If RAB, RAC combination is in parallel, then 1 by RAB plus 1 by RAC plus 1 by RBC, that equal to RA plus RB. Now do the simplification. When the resistance are connected in parallel, you can write this one R1 R2 by R1 plus R2. Similarly, we written this RAB into RAC plus RBC, that equal to RA plus RB. Make it as equation 1. This is the equation 1 we got. Similarly, we are applying another arm. The another arm consists of like this resistances, this arm RBC. RB plus RC in another arm that is RBC into RBA plus RCA by total resistance RAB plus RBC plus RCA. Make it as equation number 2. This is the equation number 2. Similarly, we can write another delta connected arm equivalent RC plus RA equal to the two resistances we have to assume. RCA is in parallel with RCB plus RAB. The equivalent resistance is this one. This is the equation 3. Make it as equation number 3. From 1, that is 1 minus 2, if we do the equation 1 minus 2, that is RA plus RB minus RB plus RC equal to the substitute the equations 1 and 2, 1 minus 2, that RB get cancelled, RA minus RC equal to, here also RAB RBC get cancelled, you will get RA minus RC equal to RAB RCA minus RBC RCA. Now make it as equation number 4. Similarly, we are doing another one. You can see here, add equations 3 and 4. If you add the equations 3 and 4, what you will get? RC plus RA plus RA minus RC. RC get cancelled, 2 RA will get. Similarly, here also RBC, RCA, RBC, RCA you get cancelled. Finally, you will get RA plus RA, 2 RA, that equal to 2 RCA, RAB by RAB plus RBC plus RCA. Now, if you cancel the 2 on both sides, RA equal to RAB by RAB, RCA by RAB plus RBC plus RCA. Similarly, we can write RB equal to, instead of A, we can write RB, instead of B, we can write C. Like that, equation 6 is assume that. Similarly, we can write RC also. If you assume this RC, how to draw, how to learn this? Any arm of star connection equal to product of adjacent arms, that is RAB RCA product divided by RAB RCA product divided by sum of all arms in delta, This is the formula we have to remember. Any arm in star connection equal to product of adjacent arms divided by its sum of all arms in delta. Similarly, if you want to convert from star to delta, suppose the circuit is like this. The delta is RAB, RBC, RCA, or the delta connected networks between the terminals ABC. Similarly, we can calculate RAC. You can calculate star to delta transformation. RAB equal to star to delta RA plus RB plus RAB by RC. How can we remember? Simply, RAB is the delta connected network which is in between the two resistances RA, RB. RAB equal to the star connected network sum of the star connected network resistances plus product of the same RB by another resistance or third resistance RC. That is RBC equal to, similarly we can write RBC. How to write RBC? RBC is the resistance here. This is the resistance we want to calculate. If star resistances are known, RP, RC, these two resistances are connected to this RBC. RBC equal to RB plus RC sum and their product divided by another third resistance RA. This we have to consider. Similarly, if you want to calculate RAC, if you want to calculate in delta from star, RAC equal to RA plus RC. What we have to remember? RAC is the delta arm. RA, RC are connected. This sum RA plus RC and product of the same RA, RC product divided by another opposite resistance RB. That we have to follow. This is the star to delta, delta to star transformations.